If you've got a question, the voices of resin are here. Oh, PlastChicks.
PlastChicks is an SPE sponsored podcast.
Hi, happy December 15th.
Happy December 15th. And when our listeners are listening to this, who knows when it'll be?
I think
It'll
it's
be January, February.
February probably.
Well,
I mean,
we're in the new year. Happy New Year.
Yeah, happy 2024 for sure. Oh man, it's a lovely day. We have a lot to talk about today. We have another, I think we have to get Connor Carlin a punch card or a coffee or something, because he is probably the number one recommender when it comes to who to bring on the podcast, and we will give him full credit for that.
Yes. We always get great recommendations for Connor. We're always delighted to talk to people that he recommends. They're always just top shelf.
Top shelf. A plus for Connor.
Thank you so much, Connor. So I'm Mercedes Landazuri.
And I'm Lynzie Nebel.
And with our powers combined, we are
PlastChicks,
the voices of resin. Our podcast is released the first Friday of every month, everywhere you get your podcasts, by SPE. And
always check out the YouTube.
Always check out the YouTube.
Which,
we were just talking about how none of us are camera ready today.
We're not camera ready, so maybe just make it an audio kind of episode. All right.
So we are so pleased to welcome our guest today, Alethea Schaeffer, Vice President of USHECO. Thank you so much for joining us today.
Thanks for having me, Lynzie and Mercedes. I'm so excited to be here. You guys are so much fun. I've listened to your podcast, and I'm super excited for the conversation we're going to have today.
Thank you so much. Thank you. We're honored to be talking to you. So tell us a little bit about USHECO and your position there.
Well, USHECO was founded in 1961, so we're celebrating 62 years in business this year. Started by my grandfather as a metal fabrication company. When one of his customers decided that they wanted to make an easel tray out of plastic, he was like, well, I can do that. And he built his first thermoformer. So that's how we got into plastics.
He built his own thermoformer?
Yep. Just a roll-in sheet-fed machine, right? And it would just roll into the oven, roll back out, and then manually pull it down over the molds and pull vacuum on it. So he created his first thermoforming machine, and we've been in plastics ever since. My grandfather unfortunately passed away 2 years ago, but my father now owns the business, and we keep on expanding, which hopefully we'll talk a little bit about that today. And as VP here, I am responsible for the sales and engineering, working directly with the customers on helping them with their designs or tweaking their designs to make it manufacturable. And then releasing our projects to the floor and following especially new projects through the floor and through the prototyping process.
Mm-hmm. And you guys also do injection molding now as well, right? Not just thermoforming.
We do. So
we do love injection molding. Listen, we don't give enough love to thermoforming. I will say that. So it's nice to have someone who has thermoforming on.
So,
but like real talk, which do you prefer? Which is your favorite? Like if you had to,
and there is only one right answer. I will unrecord this episode right now.
It's a 50% chance that you get it right.
So I'm working with SPE Thermoforming Board, which is how I met Connor at the Thermoforming conference in Cleveland. And I was recently recording a video interview for that, and I mentioned that I liked injection molding better. I thought it was pretty funny.
Yes.
So I'm a little bit torn because with injection molding, you have the high tolerance, high precision plastic parts where you're really designing more intricate features. So I enjoy that part about the injection molding. But what has been going on here, which is really exciting, is we moved from sheet fed to introducing roll fed into our business at the end of last year and into this year. So that's been like a 2-year project for me. And it finally came to fruition this year. And I'm designing a bunch of parts for that machine now. So that's pretty exciting. I get to learn a lot about the different stations within the machine and what add-ons I can add into it, which is also fun to learn about. So I'm a little bit torn right now between the roll fed and injection molding.
There. So for someone who maybe is in injection molding and doesn't know that much about thermoforming, can you just quick go over the difference between roll fed and sheet fed thermoforming?
Absolutely. So the sheet fed thermoforming, the material comes in sheet form. It's typically cut to a specific size that's going to fit into your machine. The material goes into a heater and then comes back out and is vacuumed down onto a mold. We have just vacuum forming. Some people have pressure forming as well, which also introduces air pressure on the other side of the mold, so you can form it faster and with more precision. In roll fed, it uses a roll of material, typically thinner gauge, 50 thousandths typically or less. And in your everything is in line, so you're pulling the sheet through the heat station and then into the pressure and vacuum forming station. Then typically it goes to a die cutting station where the parts are die cut out, and then it goes to a stacker, which automatically stacks the parts. So to give you an example of the difference in cycle time, it would be like 3 minutes for a cycle of say 6 parts, and the same, let's say 4 parts could be made, and 4 parts could be made in a roll fed former. And that would take about 14 seconds for 4 parts, right? So we're talking like a difference in quantity, right? Typically people who are using sheet fed are doing lower quantities, and with the roll fed, you're typically doing thousands of parts, tens of thousands, millions of parts, hopefully, when you go into roll fed.
So, and if you're talking, thicker gauge for the sheet fed, you're talking more heat required and that whole, so you're never going to win on the sheet fed, I guess. Timing wise, I suppose you could win other ways.
Right. For timing wise, so that would be, pretty similar thickness, the 3 minutes versus 14 seconds. That's like a similar thickness. You can kind of go down in thickness on the roll fed. So a little bit, because it will form more evenly than just a vacuum formed part. But that's pretty much the difference between like going from sheet fed to roll fed. And where was I going with that? Sorry, guys.
No, you're good.
Yeah. So roll fed versus sheet fed.
Thank you. Because some of us are not as well versed in the thermoforming world.
We're not as well versed in the thermoforming world.
It's us that's not as well versed.
We had no clue what we were talking about.
Not at first. Now we do. Now we're
That's the whole reason we have this podcast. It's for us to learn. And
it's a very selfish podcast. This is just what don't we know and how can we know it? So you kind of mentioned that your grandpa, like his whole thing was, someone approached him and said, I need this. And he's like, yeah, I could do that, which love that energy.
Love it.
So you grew up with a family that's, really involved in plastics manufacturing. Can you share some of the experiences or lessons you learned from witnessing your grandfather's obviously very entrepreneurial spirit in this business?
Yes, that's a really good question. So in terms of sales, my grandfather was doing a lot of the sales up until, you know, he was like 85.
Wow.
Yeah.
Love that.
And he like rarely said no. So, you know, a customer would come in with something that was outside of the box, and he would make it happen. So an example of that was a customer came in and they needed something that probably could have been an extrusion application, but he designed a bender, a heat bender, and made a bender. And so we've been making these parts for our customer for as long as I can remember, probably 15 years, maybe more. And we've carried that into what we currently do. We had a project during COVID where we were making dividers for in between photo kiosks, and the customer came in and with a design with maybe like 5 parts, and we were like, well, we can do it that way, but you know what would be better is if we made a custom machine that could eliminate a bunch of processes, and then we can do this project with 7 people instead of 9 people. And that's what we did. So we designed and made a custom machine to make that happen. Another project recently came in for injection molding. Bug. And the customer wanted to ultrasonic weld. And we have done ultrasonic welding in the past. However, it was mostly very crude. And this project required like more precision. And so we were like, I think we can do it. So we went through the process of figuring it out. We had to buy a new piece of machinery to make it happen, and learn, you know, what a sonotrode was, and how does this work, and how do you set this machine up, and we've successfully done that, and we do now 6 different part numbers that all use ultrasonic welding. And that's happened in the last year and a half.
And something that we talk about a lot on this show, but we maybe don't explicitly call it out, is design for manufacturing. And, you know, you mentioned that's now part of your responsibilities. And I think it's a skill I think a lot of people need to employ, but maybe people don't understand the importance of doing it up front. And a lot of these projects you're describing sounds like you guys invest a lot of time into the DFM for these. Can you kind of walk us through the process when somebody comes to you and says like, hey, this is my weird thing, can you guys make it? Like where do you start in that process?
Well, ideally we would start right when the part is being designed. That's the best time to start working with our customer. Hopefully we're working with the engineer who's actually making the design changes. And if they're asking questions right up front, that's really helpful for us to be able to release that to the floor and to quote it easily. It's harder when the part is already designed and it's still not quite ready for production, and we still have to do a couple iterations before we can get the project started. So ideally we're starting at that point. Sometimes that doesn't happen until the project is already designed. And sometimes the design for manufacturing allows you to be able to make the part or not, right? So sometimes we're telling the customer like in our process, sometimes it can't be made that way, but maybe in general in a production fashion, it cannot be made that way, right? Sometimes you can 3D print something or you can make a model of something. But when it comes to actual high volume production, it's not cost effective or even feasible, especially with injection molding if you have an undercut, let's say, on the inside of a part, that makes things very difficult. So yeah, we like to start that process early. Sometimes it ends up happening after we start making the product, but that makes it a lot harder to make changes because you're talking about tool changes, which are typically costly. Hopefully it's in thermoforming specifically, sometimes the changes are just on the CNC side. So those are more easily changed after the part is designed. But we do like to think about the process too of, you know, how is it going to move around our floor in terms of design for manufacturing. When we thermoform it, does it go directly to CNC, and can we pretty much not set the part down? That's kind of the idea, CNC, and maybe last year we did a project where it was a product that got CNC routed, then it had inserts put in it, then stickers put on, then it was wrapped, then it was boxed. And you know, how can we make that process so the part never sits down? I include that in design for manufacturing as well. Like, how can we make that a simple process for the floor to be able to get it done efficiently?
Now, in preparation for our talk today, you know, we of course Google stalked you, and
Obviously.
and digging into your background, it looked like you had worked at USHECO for some of your youth. Maybe not too young. I don't know. I can't assume that you're.
We won't implicate you guys in any like child labor.
I mean, it looked like you worked your way up in the company for about 9 years, I think. And then you went to school, it looked like initially for architecture, doing technical drafting and design. Is that correct?
That is correct. Yeah.
So how did that initial inclination towards architecture eventually transition towards pursuing mechanical engineering masters eventually, right? And how has this shift influenced your career, especially within the family business?
So it's a kind of a funny story. I grew up in the family business as long as I can remember, and not to throw anybody under the bus, mom and dad, but I remember I remember packing boxes as a kid, packing parts in boxes, right? And then I officially started when I was 15, working in the family business on and off, you know, summers and holidays and things like that. And I never wanted to work in the family business when I was younger, right? As I went back to school initially for drafting and design, which I really enjoyed. And I thought, wow, I can apply this to architecture, which I also love. But this was around 2008, 2009, and architecture jobs were hard to come by. And the program for architecture at RPI, which is where I wanted to go, was very demanding. And as a lot of us can probably relate, I was raising 4 kids at the time.
Oh, well, yes.
Okay.
Yeah.
Familiar.
Yep. I feel like there's a lot of women in this field who can relate to that story, right? And trying to go back to school. And so I was like, I can't do overnights in school. I have to really focus on a career path that is feasible and also has jobs when I get out. So I ended up switching to mechanical engineering, and I had no idea what I was going to do with it, but I was like, well, worst case scenario, I can probably work in some type of architecture with a mechanical engineering degree. And so I got out, and the first job that I got was in architectural lighting, which was really fun. I learned a lot about SolidWorks at that point. And
God bless SolidWorks.
Yeah, it's a love-hate relationship, but
fair.
necessary, completely necessary. But I got a lot of like the basic drafting skills that I needed while I was there, and got to work on some amazing projects. And that was what kind of got me back into manufacturing. And I never left after that. I thought I would go to architecture, but it never happened. And then I did a little bit of work in precision manufacturing and overseeing large design and builds. And then I oversaw a bearing and robotics department that repaired robots for the chip industry. And before I ended up coming back to work at my family's business, where I've been since.
So what brought you back?
I wasn't happy at my previous employment, and I thought, like, you know, for a while I'll just come back and work here. And when I came back, I was like, wow, this is actually what I was meant to do all along.
Oh, wow.
I hate it when,
Yeah.
when those stars line up.
Right.
To go out
Yeah.
and get those experiences and then realize, oh, okay, this is home.
Yep. Yeah. And it was definitely surprising that I ended up back for me, because I thought, oh, I'm going to do something different. I'm not going to work in the family business anymore. And, but I really like it. It's nice to work in a family run business, which both of the other companies were both small. And I enjoy like the freedom of it. I have a lot more responsibilities. It's not too narrow of a scope, so it keeps me interested. There's always something to work on.
And you guys are located in Kingston, New York, right?
Correct.
Is
Yep.
it as hip as I've heard? I've heard it's like the new like Williamsburg or something.
It is becoming very hip. A lot of people are moving here. We're in the beautiful Hudson Valley. It's a beautiful area, lots of scenery. And of course, as a kid, I always wanted to get out of here, but now I appreciate the area too.
So, mechanical engineering, it's a pretty obvious fit for a manufacturing company, but did you ever think, have there been situations where you've come back and thought, oh, hot damn, that's what I studied in school. Like, I can help you right out. Has there ever been like unexpected advantages to your degree in your company now?
That's an interesting question. I use less of it than I thought I would. I think the biggest part that I pulled from my degree was how to learn more than actual concepts. When you're in school, you have to just figure it out.
Right.
And that's kind of what I do now is, I walk into a project and I might know nothing about it, like ultrasonic welding or inline thermoforming or roll fed thermoforming. And I can walk into a project and be like, okay, I don't know how to do it right now, but I know I can figure it out.
It's funny you say that because, and I don't know if this is just you and I have very similar thoughts about this, or this is like I don't want to generalize it and say a woman's approach to engineering, but I've never heard a male like colleague say this before. But when I started, people used to say, oh, you must be so smart, you're in engineering. And I was like, no, I do not consider myself smart. I consider myself a real dummy. But here's the thing. I'm like, what it's teaching me is how to solve problems. It is just taking the way I would fix something and just giving me a process and forcing me to look at all the variables and test each one against what I think the outcome will be until I come up with a plan and then test the plan. I'm like, it doesn't feel like I'm learning things, I'm learning how.
Mm-hmm.
And I've never heard anyone else say that. So that's just like, I don't, that's some same vibes. Like
yeah.
injection molding.
Right. Interesting. And I also feel very similarly about, I don't feel smart because I have a mechanical engineering degree, although a lot of people say, oh wow, and a degree from RPI. But when you're in these really tough schools for engineering, there are a lot of very smart people who are there, right? And they have they have to create tests and problems so that everyone has a chance to excel, or they're giving challenging enough work for everybody. So I felt like trying to get through engineering school was definitely a big challenge because of that. And I went from like a straight A student at the local community college to I'm going to have to be okay with like B's, even a C once in a while.
I was gonna say C's get degrees. That has been my motto from.
Right. We actually gave out our first PlastChicks scholarship this year, and one of our criteria was that the student cannot be a straight A student.
Yeah.
Well, I love that you guys are giving out scholarships. That's amazing. Yeah, I feel like, you kind of have to, like, going into like a really tough school, kind of not lower your expectations, but like understand really that it's going to be challenging. I have to say it was like a lot of wine and tears that got me through school.
Right.
I actually on Lindsay's, is it on your desk now, the Sumitomo?
Yes.
She told me about a machine that made her cry, a press that made her cry when she was in college. So I painted her a nice picture of it.
But I love the Sumitomo. It is a well-documented love now. So,
So reflecting on USHECO's journey through 2020, what were the standout moments or pivotal challenges that defined that COVID era for the company?
Well, I think along with everybody else, the first challenge was to determine, are we, should we be open or should we be closing, right?
And you do work in the healthcare space, right? And
we do, but it was still a big question that everybody, even my local friends in manufacturing, we were all discussing, like, are we what was the term?
Essential?
Essential.
Essential. Are we essential? Which, sorry, wow, that was that was rough.
Yeah, we're all trying to repress that.
Yeah, right. Are we essential? Which at first it was a question mark, but then we realized that some of our products are in laboratory equipment that could be used for even testing for COVID. So that was a big challenge at first. And then we realized, our business dropped over 30% when business is closed and we had products sitting on our floor that wasn't going to ship. So the next thing was, well, we don't have really enough work for people. And we're probably going to have to cut everybody's hours so we don't have to let anyone go. Oh my gosh, I'm gonna cry.
Oh, wow.
So we had an announcement, like, we're cutting everybody's hours next week. And that was on a Wednesday. And on Thursday, I came back in and I was so upset. I was like, Dad, we have to do something. What would Grandpa want us to do? Like, he would want us to try to help. My grandfather fought in World War II. He loved our country, did everything he could, and was very into health equipment. And I was like, Dad, we're gonna make face shields. So we came in the next day and we designed a face shield and started selling it on our website and on Facebook. Then by the next day I had orders.
Wow.
And so I was like, never mind, we're not actually cutting these hours.
Yeah, that's amazing.
I
almost cried. I'm like trying to low key keep it in. Please, nobody go to the video, but
don't watch the
again. This is the YouTube version.
Yeah.
That's amazing. No, but and it also speaks to, this is like the nature of a family business. It creates that atmosphere, or can, help build that atmosphere of caring so deeply about your team.
Right. Definitely. And that's a lot of our team here was very grateful to be working and that we didn't have to cut anybody's hours. And we ended up, because we designed this face shield and I was marketing it on LinkedIn and everything, a competitor of ours was like, hey, I have a huge order for face shields. They were an injection molding company. And they were like, can you help us fulfill this order? And I was like, absolutely. So we teamed up with a competitor of ours to help them complete an order. We brought in one of our customers to also help us complete the order. And we brought in 2, what we termed remote interns, from a local school who are working at home and helping us make face shields as well. So the collaboration that happened during COVID to all work toward the greater good, was absolutely phenomenal. And that's one of the main things that I've really taken to heart. I said, I'm like, with everything that was so horrible going on, I was like, I just need one thing to come out of this that is positive. And I'm very adamant about making sure that we keep those relationships strong, and have a good support system and network, with our competitors, our vendors, and other like manufacturers locally, because that's really what helped pull us through that really tough time. And I'll forever be grateful for those who did help us. And the other thing is more practical, let's say practical application is about stocking materials. So we learned too that we're very susceptible to a supply chain issue. Not just us, but everyone. And I think we learned that lesson pretty hard during COVID as well. So that's something else that I like to keep in mind. Not that we try to stock a lot of materials, but that was an eye-opening part of what happened during COVID. In addition to the face shields, we also ended up making barriers for the local community. So COVID allowed us to expand into our local community more than we've ever done before. People were like, oh my goodness, we didn't know we had manufacturing here, or plastic manufacturing right in our backyard. Here you guys are. So that was another positive that ended up coming out of it as well.
Yeah, I love that. I know there was a group of manufacturers in Massachusetts that they were, they kind of opened up this forum of like, okay, do you have CAD files for this? Or, so everybody could share those, and they would keep people up to date on like, hey, we have extra, whatever. Does anybody need this material? Or I thought that was a really nice, if you have to be in it, it's a nice outcome.
Yeah.
Right.
Yeah, there are a lot of nice stories. Like the industrial design community did the same thing, but we do have to mention the shady. I heard it was like one of the rare times I heard like PlastChicks news on the radio. Was somebody had been hawking these, I guess because there was a shortage of test tubes, and somebody had been hawking like preforms like for blow molding as these like medical grade test tubes. I was like, oh man, blow molding on the
Wow.
Yeah. That's not quite the story we want as a feel good plastic story.
Yeah.
Well, so respecting obviously confidentiality, can you give us like a general overview of some of the projects you're working on, involved in, especially like process oriented, like, you're moving to the roll fed instead of the sheet fed, and how these new initiatives really contribute to the growth of USHECO.
Yeah, sure. So for the roll fed projects, we're working on designing a part that holds gel that needed to be very cheap, so that it could be pretty much, it would be used for a few weeks and then needs to be recycled. So it needs to be a recyclable material. It needs to have access from multiple sides. And I at first thought injection molding.
As we all do.
But after I ran some quote numbers, I realized that if I made, an injection mold for, so let's say 2 up or maybe 4 up, I could run probably 8 or 16 up, maybe, well, I would say probably 8 up in the roll fed former. And it would be a fraction of the cost of roll fed. And both design, they would be completely different designs, right? One, the injection molded part could have extra features and could have been easier to make and not require assembly. But if I did it in the roll fed, then I could get it done much better. They would stack better. and unfortunately would require a little bit of assembly afterwards. But it would be much easier to ship for the customer, and then also recyclable and use less material. So I think that's an advantage of having both under one roof, which is very unusual. It's very unusual to have all three of those operations under one roof. But that's one of the advantages of being able to do that. And so this project will eventually, we'll be making about $500,000 a year of these parts. So that's a big project that we're working on right now. We're also working on a few new projects where we're designing a pretty large like thermoform part that will pretty much expand our customers our customers' customer base. So they'll have more opportunities with this design. And we team up with another local manufacturer who is really great with SolidWorks, much better than me, to do the design work. And we're working through prototyping that for our customer right now. So when possible, we try to team up with other engineers, both locally, and we work with somebody out in the Midwest. So we have it's not just me doing the engineering work here, which is great. And our customer gets to have the advantage of multiple different engineers working on a project, depending on what the project is. So even for a small business, we're able to have, because of that network that I was talking about earlier, we have a bunch of people who can help out with these projects. So, you know, these are just like two of the many projects we have that we're working on right now. But hopefully it will continue to help us expand our business. We've been consistently growing for the last 6 years since I've been back here, and are excited. I'm excited to see what projects come in next year that I've quoted this year. Just not expecting to see them until next year, but I think we're going to be getting a new project for our roll fed machine, which will be millions of parts per year, which is really exciting.
Super cool.
Wow. So considering the dynamic nature of the plastics industry, how do you stay innovative and adaptive in your role while upholding the legacy of the family business? I mean, it sounds like your grandfather was innovative and adaptive guy to begin with.
Right? Be like your grandfather while thinking of your grandfather.
Yeah, so it is like absolutely part of what I think about on a daily basis is what would grandpa do, or, you know, grandpa would definitely say yes to this. And also, I think one of the big things to stay innovative is to be at the SPE shows, and to go to different trade shows and see what's out there, see what's new, learn from other people who are going through similar struggles and what did they do. And then one of the other things that I like to do is work with students. So we work with a couple of schools locally, and the students have great ideas about how to be innovative. I just watched a presentation from a local high school where they're using the new video game goggles, VR, to create training videos for internships.
That would be fun.
Right? So I got to put the goggles on and see what they created, and watch another intern being trained. So there's, you know, they're thinking even more technologically advanced on like some of the marketing side and, you know, HR and training. But I think the biggest thing is going to trade shows and going to even other competitors' shops and doing tours and seeing what other people are doing. How are they being innovative?
I think that's a really, you know, people say trade shows a lot, but I think they say it more as like, we got to go to trade shows, show people what we're doing so we can showcase how we are, and the fact that you're kind of flipping it on its head and saying like, well, I'm going there to like learn from other people and see what other people's doing. You know, I think that's a really smart approach to trade shows.
Mm-hmm.
Yeah, I think it was the SPE Thermoforming trade show that I just went to was really informative. We did a true cost of thermoforming forum with 4 business owners or VPs, and the discussion was so candid and open, and people seemed like they were on the edge of their seat, like listening, because the same struggles that other people are having, or you're having, other people are probably having. And some people have like just different ways of approaching the problem that could spark something that you might want to look into in your own business, which is great.
And so one last question before we close this party down. What are your personal aspirations for the further diversification or expansion of your company in the upcoming years?
So I always wonder if we should be diversifying any more than we already are.
Just add in a couple extra.
Sounds like you already did quite a bit. And you did,
Right.
Create a new machine, like
a new process. That's what it is.
Yeah. So, but one of the things that I'm looking at doing in the near future is adding a knockout station into our roll fed machine. So typically we don't have that, right now we don't have that. And I'm looking to see if that might work well for some of our future projects that I'm working on. And also we're looking at expanding the building because we are pretty much maxed out on the capacity on our floor. So, if we do need to invest in a new piece of equipment, which I expect we will, we don't have room for it. So hopefully the building, at least if we're working on the building expansion, we will be able to accommodate, a new injection molding or roll fed machine in the future.
You can always grab another Sumitomo.
Yeah.
Well, Alethea Schaeffer, thank you so much for joining us today on the podcast. It's been a delight. And where and when can people expect to see you guys at the next conference or trade show that you guys are going to be at?
Oh no, I don't know yet, but
pretending this is 2024.
I have to start scheduling 2024 conferences. I appreciate you both so much. I love what you're doing here, Lynzie, Mercedes. It's been really fun, and I appreciate you having me on.
Yeah, thank you so much.
Pleasure.